Good day to everyone. Today I am inside an energy transfer station plant room called ETS room. I am going to discuss about each components inside the ETS room and how does it work. Well, so this is the energy transfer station. Okay, instead of chiller, we do use ETS in most of Gulf countries. Well, so how does it work and how the chilled water pipe connected? You can see these are the two pipes came from the distribution companies such as Empower or Tabrid. You can see there is one return line and supply line. Okay, so return means the chilled water returned from our building, then supply means chilled water supply to our building. Okay, well, so where it is connected, let's discuss. The pipe came, you can see there are lots of heat exchanger connected. Okay, so in front of us, let us discuss how it is connected. Well, so in front of us there is a heat exchanger, and this is a plate type heat exchanger. So let us check the capacity. The capacity of the heat exchanger according to the manufacturer 21766 kilowatt. So that means 616 ton. This is a 616 ton plate heat exchanger. Well, so in the plate exchanger you can see there are some red color extension rod here. So what is the purpose of this rod? As you know, one of the advantages of heat exchanger is in future you can add plate to improve the capacity. So that's why you can see there are extension rod here. In future we can add the plate to increase the total capacity of the heat exchanger. So let us discuss what are the components and wall, isolation wall, regulating wall installed in the chilled water. Well, so this is the supply connected from the distribution company, and this is the isolation wall. This is one kind of butterfly wall to isolate the chilled water. Then this is the pressure transmitter you can see here. Okay, so which is integrated with our DDC panel. DDC means direct digital control. Then this is connected with our DPG. Okay, so also we can say differential pressure gauge. Okay, so what is the purpose of this differential pressure gauge? You can see this DPG connected across the strainer. Okay, so you can see one is connected here, then another one connected here. Okay, so here, then both are connected with DPG to monitor the differential pressure across the strainer. If it is increased, then you can see it is integrated with our DDC panel. Then by the DDC panel we will be notified. Then temperature gauge. Okay, so you can see the temperature it's showing in Celsius. In Celsius it is 5 degrees Celsius. Okay, so temperature you can see 0 to 4, more than 4.54 degrees Celsius. Okay, then this is the pressure gauge. You can see it is in PSI or bar. If bar, it is 4.4 bar pressure, almost 66 PSI pressure. Okay, so temperature, then testing port. Then this is the return line from the heat exchanger. Okay, so same here also one pressure gauge you can see, then temperature gauge. You can see the temperature and pressure. Okay, so there is temperature is almost 10.2 degrees Celsius, where our supply temperature was only 4.4 degrees Celsius, and the pressure you can see it is more than 60 psi. Okay, so and in inlet pressure also same like 60 psi. There is a minor difference. Then this is the PT pressure temperature transmitter, and this is an actuator valve. Okay, so actuator valve which is connected return of the chilled water. Okay, so to control the chilled water supply. Then again temperature transmitter and isolation valve which is connected. You can see the main distribution company chilled water line. Okay, let's see from our building line. You can see this is the building line. Okay, so one more thing I would like to mention here. If you look thoroughly, you can see the chilled water supply line connected bottom of the heat exchanger. This is the supply and this is the return line. But in other side you can see that you can see another pipe. Okay, so another pipe, this is the supply return from the building. That means this is the supply of the chilled water. Okay, so this is the return from the building, and here this is the supply to the building, right? So this is the return and supply. This is called counter flow. Okay, so counter flow means in distribution company pipe connected bottom of the chilled water, where our building line connected top of the chilled water from our building equipment such as HUFCU, whatever the equipment. Okay, so this is our building line, and here it is going to our building. Okay, so you can see there is a bypass wall. In the event of any emergency, you can bypass the chilled water. Okay, so for any maintenance, bypass wall. Well, so same here one you can see the temperature transmitter, pressure gauge and temperature gauge. Also in the building supply line, you can see there is a pressure transmitter and also temperature gauge. Here you can see the temperature from building slightly higher than the temperature of distribution company. It's showing 5, 6, 7 degrees Celsius, where our distribution company temperature was only 4.4 degrees Celsius. Okay, so it is connected with our main line, and this line is connected with our pump. Okay, you can see there are several heat exchanger, 5 heat exchanger. Then it is connected with our pump. So let's check how it is connected with our pump. Okay, well, so this is the line connected from our heat exchanger, and see it is entering to our pump room. Okay, so entering to our pump. Let's go to the pump room. Well, so it entered to the pump room, you can see. Okay, then you can see there are lots of pump connected to our chilled water line. In the pump, you can see there is suction and discharge. Okay, so in the suction also there is pressure, and discharge also there is pressure gauge to monitor the pressure. And across the pump, you can see there is a differential pressure switch to monitor the pressure across the pump, which is integrated with our DDC panel. Okay, so DDC means you can see there is a DDC panel, direct digital control, where all the pumps are integrated with the differential pressure transmitter connected across the chilled water according to the command, and it is continuously monitoring the differential pressure across the chilled water. When the differential pressure will increase, then our VFD, this is the VFD panel, you can see the VFD will be ramped up. When the differential pressure decrease, the VFD will be ramped down. You can see the pressure, you can see the frequency is varying. That means it is depend upon the differential pressure across the chilled water supply and return line. Okay, when the differential pressure will increase, then the frequency will be increased. When the differential pressure decrease, the frequency will be decreased. One more thing I would like to mention here. Let's say if there are 2 pumps are running out of 5. If one of the pump will be tripped, what will happen? Let's say this chilled water. Okay, so pump number 3, it will trip, what will happen? If that pump will be tripped, if someone will off manually, another pump will be on with auto. Okay, so that is the integration. So if one of the pump trip or off, then another pump will be on in auto. So that is how our MCC does work. Well, so this is the chilled water dosing system. You can see it is connected with our chilled water. Okay, so chilled water chemical dosing system. This is the manual part. Here we will add the chemical. Okay, then as per the demand, it will inject the chemical to our chilled water.